So what we're going to do today is differentiate exponentials, but these differentials are going to require the use of the function rule. So what you can see here is that we have y is equal to e to the power of 3x plus 4. So it's not as simple as differentiating e to some power because the power is a function. So we have a function within a function. So hopefully you'll remember that one of the ways that we do this is the u substitution. So we let u equal to the function within our function, which in this case is 3x plus 4. But in order to do that, then we also need to know what the derivative of u with respect to x is. So in this case, that's 3. And the reason we need to know that is because we are using the fact that dy over dx can be found by doing the differential of y with respect to u times the derivative of u with respect to x. Okay, so we have du dx, we need to find dy du. Okay, so go back to your function and we know that y is equal to e, but now it's to the power of u because we have let u equal to 3x plus 4. So if I differentiate that with respect to u, then I get e to the power of u again. So using dy du times du dx, we know that dy du is e to the power of u and that du dx is 3. So this is equal to 3e to the power of u. But we said that u is equal to 3x plus 4. So you substitute that back in and you get 3e to the 3x plus 4. Now you can go through these steps of the u substitution for every single one of these, but what is happening there? Well, what we're doing is we're taking the function in the power and we are differentiating it, and then because this is an exponential, when we differentiate an exponential we end up with the exponential back again. We can come up with this general rule that if y is equal to e to the power of fx, then dy dx is f dash x, the derivative of the function within the power, times e to the fx. And that's a much simpler way of differentiating exponentials. Okay? So, having a look at this first example, e equals 4x minus 7. So then we know that y dash, or y dx, whichever way you want to write it, is equal to, look at the power, 4x minus 7. The derivative is 4e to the 4x minus 7. That's it. So what about the second one? Well, dy dx is equal to, the derivative of the power is minus 9 times 2e to the minus 9x, okay, which you would then be expected to simplify. Negative 9 times 2 is equal to negative 18 e to the minus 9x. And it works no matter how complicated we make the function within the function. So looking at example number 3, if you think you know what to do, then pause it and then come back and check your answer. Okay, so we know that when we differentiate, we end up with the derivative of the function, and the derivative of 1 minus x squared is minus 2x, and then we multiply that by our original function. It's just minus 2x e to the 1 minus x squared. So it doesn't matter how complicated it gets. So question number 4. Now this is going to involve a little bit more work. This is a function of a function within a function. Sounds really complicated, but just take it one step at a time. Okay, if we had something in the brackets to the power of 4, then when I am differentiating this, what I would do would be to bring the power down, keep the thing inside the brackets, take 1 away from my power, and then I multiply that by the derivative of what's inside the brackets. So what's inside the brackets? E to the power of 2x. So the derivative of that is 2e to the power of 2x. Derivative of minus 3 is nothing. That's it. You'd be expected to simplify it. So we're going to end up with the 4 times 2, so 8 e to the 2x outside of e to the 2x minus 3 all cubed. Alright, so let's have a look at the next one. We have y equals x cubed e to the power of 2x. Who remembers which one we're using for this? This is the product rule. Okay, so what is our product rule? Y dash equals uv dash plus vu dash. Okay, so in this case, u is equal to x cubed, so u dash is equal to 3x squared. V is equal to e to the power of 2x, so what's v dash? Well, that's 2e to the power of 2x. So then, when we differentiate y, we get u v dash. So we get x cubed times 2e to the 2x, and then we add, because remember, product plus, so we're going to add v, so e to the 2x times u dash, so 3x squared. And then you can simplify. So we have common factors of, we can take out an x squared, and we can take out an e to the power of 2x. So that's my common factor for the two terms. From the first term, I'm left with the 2 and an x, and then from the second term, I'm left with a 3. So that's what you need to be able to do exercise 4.2. Take it one step at a time. You can do this. There's not much new here. As long as you take one step at a time, everything will be fine. Good luck, and I'll see you in class.